Hello everyone online. Thank you so much for tuning into our session on GeoAnalytics and ArcGIS Pro, Geoprocessing in parallel using Apache Spark. I'm Sarah Ambrose, and beside me I have Bethany Scott. As you know, the 2020 Esri Developer Summit is not on due to coronavirus, but we are taping this and making it available on YouTube where you are watching it. So let's get started. So this presentation really answers a few questions, and some of those might be, have you ever had analysis fail because your data was too big? Or have you ever waited for a tool to finish and it took forever? So maybe it felt like forever, maybe you wanted a bit faster, but these are questions that GeoAnalytics helps to answer. So what is GeoAnalytics? GeoAnalytics is a toolbox that parallelizes computation to quickly analyze large amounts of vector and tabular data. So focus here is parallelize. So on your machine, we're using multiple cores to run the analysis, and vector and tabular data. So we're most interested in feature data. So point line polygons. This isn't a raster product. There are similar raster products, and there will be videos available for them as well. So if you're interested in that, definitely check them out. And GeoAnalytics is a collection of analysis tools to identify patterns, relationships, anomalies, and incidents in large amounts of data across space and time. So when you have large data, often you have a large amount of points. Obviously, the geometry and location is very important. We are all GIS users, so we know that, but time is also really important because usually when we're accumulating large data, there's some kind of timestamp. That seems to be very frequent, like events in time. So how is GeoAnalytics actually faster? So this is because we're using Apache Spark. So we've taken Apache Spark, we've rewritten these tools, and we've put them in a toolbox that's just ready to use so that you can open up ArcGIS Pro, use those tools, and under the hood, Apache Spark is running on your machine. There's no setup for you, it just works out of the box. So why would you actually want to use it? If you're not already super compelled by the reasons I've said earlier, some of them are your existing tools and workflows aren't processing data fast enough. You want to make your data into something more manageable to use in other analysis. So maybe you have a huge point data set and you're trying to figure out how can I get it to a smaller point data set or find areas of interest to use in other typical pro workflows. Or maybe your data has a ton of noise and you want to explore it to bring out what's important. So you're looking for those needles in a haystack. The last one is some of the tools are really cool. We do have tools in GeoAnalytics tools that are not there in ArcGIS Pro. So something like Reconstruct Tracks, which we'll talk about later, is something that you might be really interested in using. Doesn't mean you need to have huge data sets. It's just you want to take advantage of the analytics that we have available in the tool set. So I have 3 examples of analysis that you can run, but throughout this session, Beth will be giving some demos, and we'll talk about a few examples as we go, but here's some quick examples to give you an idea. So which stationary pressure sensors in my pipe network have experienced anomalous events in the past 24 hours, and where are their hotspots of anomalous events? Where have my delivery trucks traveled, and where is the highest density of unique delivery truck paths? Where do delivery trucks travel the slowest? And where and when are events happening close together in space and time? So how do I actually access GeoAnalytics? There are 2 products right now for how you can access GeoAnalytics. So the first is GeoAnalytics Server. This is distributed processing across multiple server cores and machines with ArcGIS Enterprise. And the second, which we are talking about today and the newest, is parallel processing across cores on your laptop or desktop with ArcGIS Pro. So GeoAnalytics Server, we do have a full other talk that we are recording. So if you are interested in GeoAnalytics Server, you want to run your analysis across multiple machines, or you want to use ArcGIS Enterprise, that is the product for you. And that would be the session I recommend you check out. And then GeoAnalytics Desktop, what we're talking about today is if you have an advanced license in ArcGIS Pro right now, you can go run these tools if you have Pro 2.4 or greater. I do have a few more slides talking about the differences, but again, the focus of this presentation is GeoAnalytics desktop tools in ArcGIS Pro. So I have 2 or 3 slides on when you would use desktop or server. These are kind of a high-level overview. There is a link to a blog post in the slide deck, and I will also be posting it on the YouTube channel so that you're able to access any links that I talk about there, or the YouTube. video, not the channel. So use GeoAnalytics Server when you want to bring big data analysis to your entire organization. So this is something that would be on your portal. So anyone that has the privileges could access GeoAnalytics Server. You want to leverage the power of one or multiple server machines. You want to connect to external big data storage and existing web layers, or you want to extend a custom analysis through something like Run Python script, and we can link to a blog post so you can understand that workflow a bit. GeoAnalytics Desktop on the bottom, which is what we're talking about. You want to process local data, so data from files, databases, shapefiles, faster than before on your own desktop machine, or you want to prototype workflows you want to use with GeoAnalytics Server. One really big benefit of GeoAnalytics Desktop is that it's very easy to get started. If you have Pro, you don't need to do anything else. You are ready to go and try out those tools and access them. So I do think for most people, GeoAnalytics Desktop is going to be the place they want to start. I do have an expansive table on some comparisons. I don't want to go through it completely. It does just outline the input and output data types, how you can scale out the analysis, the tools, and interface. Because this is a video, I'm just going to leave this. You can pause if you want to look at it. And then you can also link to the blog post that covers it more extensively, because it's not the purpose of this presentation, but I do want it to be available to you. So with that, Bethany is going to show us how we actually run a tool, because right now we don't have anything too concrete yet. So Bethany, let me hand it over to you.
Thank you, Sarah. So I'm going to demonstrate for you the power of GeoAnalytics desktop tools. And I'm going to do this by aggregating 125 million features into 15-kilometer hexagon bins across the entire continental United States. So the tool that I'm going to use is a GeoAnalytics desktop tool under the Summarize Data toolset. It's in a familiar location with all of the other toolboxes that we're already used to working with in our daily workflows. So the Aggregate Points tool is a great first step for many analysts who want to gain better visual insight into their big and noisy data sets. So what we're going to do is we're going to go ahead and select this data set that I have in my map. These are the centroids of 125 million buildings in the United States. And we're going to aggregate these into hexagon bins, as I mentioned before. And we're going to give a resolution of 15 kilometers. At this point, the tool's ready to run, so I'm going to go ahead and click the button. But while this is happening, I'm going to take a moment to emphasize the environment variable parallel processing factor. So all GeoAnalytics desktop tools have this parameter. Because GeoAnalytics desktop tools leverage Apache Spark to parallelize your analysis, we offer you this parameter so that you can control how many resources are actually being thrown into your GeoAnalytics analysis. So for the sake of time, I do have a loaded layer in my map here. You can see that this analysis took 41 minutes on my desktop machine. This analysis I was previously unable to complete on my desktop without using GeoAnalytics desktop tools. So immediately it becomes much more clear where the patterns and trends are in this huge data set. The ability to crunch large, noisy data sets into something more meaningful, even visual, is an incredible benefit of using GeoAnalytics desktop tools. So with that, we've introduced the familiar access patterns of GeoAnalytics desktop tools, and you've seen the power that they have to crunch your big data sets into something useful. And with that, I'm going to hand it back over to Sarah.
Cool, thank you, Beth. That was very nice, and your map is very pretty, so I appreciate that as a non-good cartographer person. So Beth just showed us a very quick, simple way of running a tool and a simple tool like Aggregate Points. We'll talk about later how you can change parameters. So that tool took about 45 minutes, but if you wanted to do something different, Aggregate Points could be completed in a few minutes just based on the parameter options. So that's cool and interesting to learn about for GeoAnalytics. So I want to go in the analysis overview. So really the crux of this tool set in Pro is the tools that we have available. So with that, I counted it this morning and I already forget, I think there are 17-ish tools available in Pro. We've grouped them into tool sets to help you logically understand what the tools do. So analyzing patterns is more statistical. It's looking for trends, things like density, hotspots, point clusters. Proximity are just, it's just create buffers. Manage data. This is more your simple kind of classic GIS tools like calculating the field, clipping layers, dissolving and overlay. Summarize data, these ones are very big data focused. So these ones are often to help you summarize a really big data set into something more manageable. So aggregating points like Beth showed, something similar would be Summarize Within, where you could summarize point, line, or polygons into polygons. And then lastly is Find Locations. Most of these are fairly new to GeoAnalytics, so for example, detect incidents and find dwell locations we will talk about later on when we talk about tracks, but those are tools that are just there for GeoAnalytics. So we do have a set of tools specific for big data. Some of them are similar tools and familiar tools that you would recognize, like clip layer or dissolve boundaries, but some are unique to GeoAnalytics and interesting in their own right. So with the analysis capabilities, something that's really important is that we work in both space and time. So not all tools require time. Some it is an optional thing and some it is required. But as I mentioned before, it's really critical because so much of the big data that you see, that we see, has a time component. So you can use GeoAnalytics tools to perform spatiotemporal analysis. And the way that you do that is you define your temporal input data. So the two ways that we do that, and it's very similar to what you might already do in Pro, or on your feature service, is you can have an instant, so that's just a single moment in time, so you have one timestamp, or you can have an interval, which is a duration in time, so you have a start and end time. When you're using time, you can obviously visualize your results in Pro. If you wanted to create a feature service, you could do that with Map Viewer as well. So about those spatiotemporal capabilities, I'm kind of going to go into a few different temporal things that we have. So the first I'm going to talk about is track analysis. Then I'm going to talk about other ones like spatiotemporal joins, finding spatiotemporal clusters, and then time stepping. So track analysis might be something you are familiar with, but it might also be something you have no idea what's going on. So I wanted to start with, what are tracks? So here I have a time slider or a time representation on the bottom, and then I have points. So tracks are really just measurements recorded over time. That is the simplistic version. So this could be a vehicle moving, an animal moving. It could be a sensor that's stationary. It doesn't have to be moving in location for all of these tools. But I'm going to go through, I think, 4 tools that we have that deal with track data and kind of give you an example of what we can do with them. So the very first is to visualize where tracks have gone using breadcrumbs as inputs. So this is something that we call Reconstruct Tracks. On the left here, I have a bunch of hurricane recordings. So measurements of a hurricane at a certain time. As you can see, it's hard to tell, is this one hurricane? Probably not. That would be a horrible hurricane. Is it many hurricanes? How can we visualize the hurricanes? And with using Reconstruct Tracks, because each one has a track identifier, so maybe the hurricane name as well as a location and a time, we're able to reconstruct the tracks to see where they've been traveling. So here I see those tracks with lines. You can also optionally buffer them by some attribute, which can look interesting. I think here we've buffered it by wind speed, so we're able to see how the hurricane's changing over time as well. This one's definitely one of our most powerful and popular tools, especially if you're using something like GeoEvent. You're ingesting data, and then you want to visualize where those tracks have actually gone. So Reconstruct Tracks is something that we see most users kind of starting with if they have track data. The next one I want to talk about is detect incidents. So this is finding features that meet a specified condition. So this condition can be really simple. It could be something like the track name is equal to Beth. That's fine, but it can also be something where you're using the track history with something that we call arcade expressions. So you could say something like, find me the features where it's greater than the previous 3 features summed. So we have something called track history where you're able to do math on them, and you'll actually learn a bit more about that in the next slide where we talk about calculate field and expressions. But this one's very powerful to pull out the features that you're most interested in. Calculate field does not need to use tracks at all, but it is an optional parameter and something that you can use. So calculate field is obviously a tool where you're creating a new field. you can, just do something simple like field 1 plus field 2, but then you can also do something with a track expression, which would look kind of like this. So again, I have my axes with my time. I have a bunch of features, and each of those features has a value. So the first one has value 1, second has value 2, third has value 2, 8, 12, 5, 9, 32. These are just random values I've created because I just want to walk through the math of how a track expression would work. So imagine the expression that I'm using is the value of t minus 1 plus the value of t plus 1. So I'm looking for the sum of the previous and the next value. So at the very first one, at the first feature where its value equals 1, I'm looking at the previous value, which doesn't actually exist in this case, plus the next one, so 0 plus 2. So that one would end up with a calculated value of 2. The next one where value equals 2, the previous is 1 and the future one is 2. So it's going to be 1 plus 2. The total calculated value would be 3. And then it's going to continue like that. So the next one, 2 plus 8, and then continues on throughout. So you can do a simple-ish expression like this, just looking forward and backward, but you can also get very complicated and do some very interesting expressions. These same expressions are available in Detect Incidents, the tool I talked about the previous slide. And so you can start doing some complex calculations to detect which features you're interested in. The last one I have is our newest track tool, which is Find Well Locations. This was after gathering a whole bunch of user feedback, and we found that people are really interested in finding where objects are remaining stationary or near stationary. So here we have a track. I believe this is Uber point locations. It's traveled in the city. And we wanted to find out where they're dwelling, which in this case is probably idling or parked. So running this algorithm, we specified a time and a distance, say, hey, let me know if they are, within 10 meters for more than 20 minutes. They haven't traveled 10 meters and they've been there for 20 minutes. And we resulted in a convex hull of that dwelled location. There's different ways you can represent the output. You could do a single point, you could return only the dwell features, but here the convex hull is helpful for visualization to help understand. Those are the 4 main track tools, but something that we always like to remind you is you can chain these tools together. We never want to say use these GeoAnalytics tools in isolation. It's always going to be part of a workflow that you're integrating. So for example, this one that's really popular is putting Reconstruct Tracks, don't reconstruct your plaque, and Summarize Within together to create a heat map of tracks. So it's very obvious on the left where you can see that the tracks have traveled in certain areas. You could always just aggregate your points, but you won't actually see where the track has traveled. So there's real value in reconstructing into a track first to understand where there's actually the highest occurrences. And Beth recently actually wrote a great blog post on this and a great example, so we will link to that as well at the end. So we do have some additional space-time analysis as well in addition to tracks. We have spatiotemporal joins, which are super, super powerful, time stepping, and spatiotemporal clustering. I've listed the tools that each of these algorithms or components are part of, but I'm going to go through each one in a slide as well. So spatiotemporal joins allow you to join features based on their relationship in time. So the tool we have called Join Features allows you to specify a spatial join, which you're probably familiar with, say a point in a polygon, a temporal join, and an attribute join. So you could use 1, 2, or 3 types of those joins. It's totally up to you. It's very flexible. But on the top row, I have a space-time join of a polygon to point features, but I'm also doing on the z-axis or z-axis, axes, sorry, overcomplicated for me to say z. On the time axis, you can see that I'm also just interested in the points within the polygon interval. So the points are an instant and the polygon is an interval, and I'm joining based on that temporal relationship. The same can be said for the bottom. So here I'm doing a spatial and temporal join at the same time. The points are within the polygons in both space and time. And I believe there's about 13 different relationships you can do with time, so there's a lot of flexibility with those and what you can actually do. The next one I have is time stepping. So a lot of the times when we're aggregating, we're really interested in doing what Beth did, but sometimes we want to aggregate in time as well. So you can do something where you analyze your data at specified intervals. So you have 3 parameters that you can specify. You can do an interval, so how long you want your time step to be, the repeat, how often you want to do it, and the reference is how you align it. So if I wanted to analyze every Monday, I don't care about the data on Tuesday through Sunday, I just want to have time step values for Monday. I could do an interval, which is 1 day. The repeat would be 1 week. So every week we're going to look at 1 day, and the reference would be some Monday. So you can basically say the reference would be this past Monday, and it will go forwards and backwards in time to do the time stepping. So it doesn't need to be the start, it's just the alignment. And let me just refresh this so you can see on the right, I've been doing some time stepping of lightning. So as the lightning moves, you can see that the time step with the time slider in Pro is visualizing those things. Visualizing the results. Sorry about that, I hit a blank there. Spatiotemporal clustering is new at Pro 2.5, and it is something we're very, very, very excited about because it is very cool. We previously offered just spatial clustering. So you're looking for clusters of points based on a distance. In this past release, we worked very hard to implement a spatiotemporal clustering, so you're able to find points together in space and time. We do have a demo of this, and we'll have a blog post coming out soon that we'll post. But basically, this is Uber point data here. We're looking at Uber pickups, and we wanted to find clusters based on the number of features in the cluster, a distance, and a time. So I believe we're looking for at least 20 pickups in a cluster. They have to be within 50 meters and 10 minutes of each other. And you can see the purple are the inputs. The gray results are noise, so those ones are not part of a cluster. And the green and the beige color are 2 distinct clusters. And the reason they're kind of intermixing there, which is interesting, is because they don't overlap in time. So if you change the time slider a bit, you would see 2 distinct clusters that I think they're actually a day apart from each other. So with that, Beth is going to give us a demo on track analysis.
Thank you, Sarah. So as Sarah has introduced to us, we do have a few track analysis tools, but the one that I'm going to demo today is detect incidents. So I'm going to detect ozone anomalies using the GeoAnalytics Desktop tools. This tool is going to work by searching through about 300 unique sensor locations. You can see these in my map here. So in total, this data set is actually 55 million records. Although it doesn't actually look like it in this map, if you scroll down here in my notebook, oh yeah, I should emphasize that we're running this analysis in notebooks for ArcGIS Pro, which is a great new feature that we love to run our GeoAnalytics analysis in. But yeah, so all of these 300 sensors have thousands to tens of thousands of features at each location. So for this one unique location, we have over 14,000 points. So you can see how this data set would add up quickly. So we're going to search through all of these readings using the Detect Incidents tool to find the sensor readings that meet a certain condition. So as Sarah mentioned before, we're going to use an arcade expression to do this. The expression you can see here in my code is going to find an average of the sample measurements over the last 8 hours. And it's going to take the average of this, and if it's greater than 70 parts per billion, this average, then it's going to say that this is an incident. So I'm going to go ahead. You can see here I filled out my tool using ArcPy. I'm going to click the Run button here, and we'll get some messages appearing in our notebook. But I have pre-analyzed this. You can see that this analysis right here on my desktop only takes 20 minutes to search through these 55 million records. But I've added this image here, this time slider, that you can see how the results would be much more meaningful to you to figure out where those problematic ozone readings are occurring. So in ArcGIS Pro, one of the great benefits is that we have this time slider effect here, as Sarah showed for a lot of our other track demos, or track images. But what we're looking at is where these hotspots of incidents are occurring over time. So you can now visually compare where patterns are happening, but you can also visually detect anomalies. So this is incredibly effective for you to go ahead and implement your results and your findings to prevent and mitigate future events. So now that you know where these problems are happening, you can go ahead and see what's causing them. And with that, we have seen how GeoAnalytics can crunch through sensor locations with tens of thousands of records using tracks to find where important and problematic incidents are occurring so that you can apply these to your daily workspace and workflows. Thank you. Back to Sarah.
Cool. Thank you, Beth. And yes, Beth mentioned that she's using the Pro notebooks, which are great for exploring your data and something that's new in this last release. So we definitely recommend checking out any videos about that, and we'll try and link to a good example one so you can see where to go from here. Back to my screen. So we do have some considerations when running GeoAnalytics desktop tools. As much as possible, we do try and make sure everything is integrated into Pro as seamlessly as possible. Because we're using Spark, there's often some tiny little quirks that we want you to be aware of so that you're able to consider them doing your analysis. So here are our main need-to-knows when you're running analysis. GeoAnalytics tools use Spark, so this means that we automatically use 90% of the memory on your machine and all of the cores. So for example, when I use this on my huge 36 core machine, we can see that it was actually analyzing on all of those cores and using that. If you want to use less, you can control that through the processing factor that Beth mentioned to control the core usage. So that is just an environment setting that you can change, and it will modify how the cores are used. The startup time, so with GeoAnalytics, every time you run the tool, it's going to automatically start up Spark. This can take a bit longer than you might expect if you're expecting like a 1 second tool run. It can take about 5 to 15 seconds to start Spark. If you're using a larger data set, you will not notice this at all. Like if Beth is running a huge tool that takes 20 minutes to start up, doesn't matter at all, but there is that loss up front. So if you're analyzing, a few hundred points or a few thousand points, you definitely might notice it. And in that case, there might be an equivalent tool in Pro that you should be using. So for example, if you were doing the GLR tool, generalized linear regression, on a few thousand points, it might be better to use the tool in the spatial stats versus the GeoAnalytics. If you were using a few million or a few 100 million points, then definitely the GeoAnalytics tool is going to be more beneficial for you. A lot of that will be trial and error because, as I'll talk about in the next few slides, the processing time, there are ways to figure out and change it, but it does rely on a few different things. So there's no exact answer on when to use one or the other. We do try and document as much as possible in the tools where the equivalent tool is and when you should kind of try and switch or when which one might be better. And then lastly, it's a different implementation of the tools. So if you run create buffers in GeoAnalytics and then you run the other buffer tool that you've always run, the results might not be exactly the same. And here's just an example of the differences. So the yellow one is GeoAnalytics and the blue one is the buffer result. Because we're working with big data, we are trying to figure out ways to simplify processes and run them faster. So here we just don't have as densified circle result, for example, on this buffer. Generally, you can see that they're very, 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 very similar, but there will be these subtle differences in tools. And again, we try and document all of these in our topic about considerations to know when you're using GeoAnalytics, as well as the tool themselves. We'll let you know about that there. So as I mentioned about performance, there isn't always a best solution. And when I sit here and I say like, hey, what's your favorite tool and how long does it take to run in Pro? You know that there's not a correct answer, right? There is going to be a number of factors that go into that. The person, if you talk to someone else that you worked with, there is no way they're going to say, hey, my favorite tool is buffers and it always takes 1 minute and 42 seconds. Like, probably impossible that would happen. So there's different factors to talk about. So they're just good to be aware of. So the first one is input data. Obviously, the number of features matters. We are geared to work with bigger data sets. But if you scale up your data, it will take longer. The geometry type and number of vertices are probably ones that are more overlooked. Number of features is very obvious, but the geometry type points are always going to work a bit faster than something like a polygon, but they're not really directly comparable because they're not usually used in the same tools. The number of vertices for a polygon definitely would influence it. So if you have a huge polygon, just a single polygon with a huge amount of vertices, even though that seems like smaller data, that could definitely be more complex and harder to use in a tool. We should be able to work with the one polygon. That's just an example or an exaggeration, but the number of vertices does matter. The next one would be data sources. So co-location is super important if you want it to run. So much so that we don't currently support feature services as our input, because the time to grab the service from the server, bring it down to be used in GeoAnalytics desktop tools is too much, and at that point you should probably be using your GeoAnalytics server to do the analysis. For co-location, it also could matter if you're on a network share or if it's stored locally on the machine with Pro. As much as possible, we'd recommend storing it on the machine. We realize that's not always possible, so if the network share has good performance, that would be much better than a very slow network, obviously. And then the other one is file type. Shapefile, I cringe to say it, but shapefile is going to be much faster as input and output for analysis in these tools, and we know that. When possible, we would recommend using a shapefile. There are obviously limitations with null values and with the size of a shapefile maxing out at 2 gigs. So we realize that's not something that we can say in all cases use a shapefile. We definitely support file geodatabase. You probably won't always notice the difference, but when possible, we would say use a shape if you can, but definitely read the doc about considerations for using shapefiles and file GDBs as well. And then enterprise geodatabase we support as well. Again, it's probably going to be a bit slower than your file GDB. The next one is tools and parameters. So the tool that you are using matters a lot, as well as the parameters. Some tools will be very memory intensive, some will not. Some tools you could run, so for example, find point clusters is very computationally expensive. So the same data set might struggle on find point clusters, and it would complete in minutes or seconds in something like aggregate points. So that's just something to be aware of, as well as the parameters that you're using. In each of the tools, we've tried to document how you can modify parameters to make something simpler or faster. So for example, how many neighbors do you have? If you're doing calculate density versus aggregate points, it's a very similar output. I would definitely say consider using aggregate points over density because there's no neighborhood search in aggregate points. For calculate density, if you up the number of neighbors or the neighborhood distance, it's going to suddenly take a lot longer to run. And then lastly, distribute the data. So we do have parameters in some tools that can help you chunk up the data a bit. We have time boundary parameters in our track tools. So do read the doc and recommendations on how you can help improve the performance based on the tool parameters. And then lastly, the hardware. So this is obviously very important. Beth has been running on a 16 gig machine, I think with 4 cores. That's usually what we're running on and testing on here at Esri, but we do have bigger machines as well. As you saw, I pulled up my 36 core machine with I think 256 gigs. That is not expected by any means. That is just a super big machine we have to make sure that we're pushing the software and testing out different things. But RAM is definitely the one that we see where if something might be having a hard time on 8 gigs of RAM, something like 16 gigs, suddenly that job will fly, or 32 gigs if possible. Upping the RAM seems to be the most direct, fastest way to get something working more quickly. Drive space and speed, and I'll talk about that a bit about in the next slide, and then the number of cores as well. But 4 cores is fine, 8, 16, those are all very reasonable. We're not really expecting much more than that. Some details on the RAM. So as I said, increasing the memory if possible. So 64 would be awesome, but by no means expected. 32, 16, etc. I think the minimum requirements is 8. So we are expecting things to work on 8 gigs of RAM. And definitely check the documentation to double check if you have min requirements. But here it's like GeoAnalytics will improve as you up the requirements. If the job can't be completed in memory, it will spill to disk. So this is something that's baked into Spark. If the job's trying to run, it runs out of 16 gigs of memory or whatever it is, it will write to your temp drive. So you do need to make sure that your temp drive has enough space. By default, it's going to use your Windows temp drive, but you can just change your temp drive in the Windows settings and Pro will automatically use that new location. So make sure you don't have this tiny drive for your temp drive that gets filled up quickly. You'll want to put it somewhere with enough room and a fast enough disk. So that kind of concludes our considerations for ArcGIS Pro. I do want to talk about what if I need to run on even bigger data. So I've maxed out my one machine. Things aren't working as quickly as I need. I think I need more machines. There's only so much that we can do with one machine, right? We need to scale out at some point. And in that case, we would definitely say, look at GeoAnalytics Server. So in most cases, GeoAnalytics Desktop is going to be great for most of your workflows. But if you're finding that you need multiple machines with multiple cores, GeoAnalytics Server can allow you to scale out to 3 machines with ArcGIS Enterprise. We do have one more thing we want to talk about, which is what's next. I kind of touched on that 2 gig shapefile limitation, and we do have something coming in the works that we can work with many more flexible data sources. So this is totally a work in progress and a sneak peek. This does not mean 100% it will be exactly as we are showing in the next release, so please don't go tell everyone all about it and know that this is happening. We are working on this. Things are not finalized. We just want to show you what we can potentially do soon. So yeah, we just don't want to hide it from you because I think you're going to be excited. So we want you to be able to easily connect to your data. We have a very similar concept in GeoAnalytics Server, and we want to bring that to desktop. So we're allowing you to read directly from collections of data sets in a directory. So these data sets can be delimited files, shapefiles, Parquet, and ORC. So here I have a folder structure. I have a directory called demo BDFS, which is totally just a random name. And then in there I have a bunch of folders. So our proposed plan is I will be able to register demo BDFS, and in it, every folder will represent a unique data set. So as a user, I would be able to browse to the dataset Lightning and use that data set for analysis. Within Lightning, this is where the flexibility really comes in. I can have multiple data sets. So Lightning here, I have 12 shapefiles. When I browse to the Lightning data set in the tools, it will automatically use all 12 of those shapefiles as a single data set. So the structure will be important. The demo BDFS, it's only the directories below that registered location that will be a single data set. But every single folder will be its own data set. The only requirement is that the data sets within have to have the same schema. So Lightning 1 and Lightning 2 have to have the exact same schema as each other, and that way they're able to be used. The same will go for delimited files. You could have, a folder with a bunch of delimited files as long as they have the same schema. That could be text. It's very flexible. And then you could also have shapefiles and Parquet. So with that, I'm going to hand it over to Beth to give a quick demo, and I am sorry you were seeing a pop-up that I thought had been turned off.
Thank you, Sarah. So I realize right now that this is not the most exciting place to start a demo in File Explorer, but I am just going to talk a bit about the file source that I'm going to use, like Sarah just explained. So upcoming, we have something called Big Data Connections. And this is the file source that I'm going to use to create one out of. So here, this parent folder BDC source, I have a few different data sets, not unlike Sarah just showed us, but I'll dive into it a bit more. So I have here this crimes data set here. This will be registered as a single data set. Within it, it has a subset 1 and subset 2, and they each contain multiple shapefiles. Similarly, my ship locations are represented as a single data set, but using multiple CSVs and multiple subfolders. So my ships are collected by zone and by month, and they're splitting them up by zone and parts of year. Something else that's a pretty common example is just having a bunch of CSVs dumped into a folder, and they all contain the same schema. Maybe you're collecting them monthly, but you want to use them all at once in your analysis. So this is something that we support as well. I'll just hop into some less familiar or less common GIS data formats. So here we have some hotels in Parquet format and hurricanes in ORC. So now we've seen a bit about the data sets that I'm going to register and how they're all going to be, all of these folders are going to be recognized as a single data set, but they all contain extremely different structure underneath. So let's go ahead and hop into ArcGIS Pro, and I'll show you how I'm going to register my big data connection. So I have this pre-populated tool here. What I've done is given my big data connection an output name, my big data connection. Very interesting. And an output location is my default location to my project folder. And the source path is that location that I've just shown you in my file explorer. So I'm going to go ahead and click run. And what this is going to do is GeoAnalytics is going to be doing its best to auto-discover those data sets. So everything in this folder location here, GeoAnalytics is reading through, and it's doing its best to set field names, time properties, geometry properties, etc. But I do have an example BDC that's already completed here. Just for a quick look at the back end and how the properties are stored and what we're discovering. So for my big data connection, I have this path for where my data sets are stored, sorry. Then I have a list in here of all of my data sets. First, we have this bus location CSV. You can see that it knows it's a delimited file with all of its properties. We've discovered the fields, their names, and their types. So we have some things like the vehicle ID, the lat, and the, I'm not clicking on anything right, the lat and the long, other features like that. And now, after all of these fields, we get to the geometry and the time. Oh, no time on this. We get to the geometry. So you can see that GeoAnalytics has done its best to find that we have fields in here called long and lat, and we have represented this data set using X and Y respectively. Another example, we'll hop into something with some time. Here we have some crimes, and we have found that this data set has a field named date, and GeoAnalytics has parsed those, the field values to find that the format being used for date is month, day, year, hours, minutes, seconds. So that's how it would be registered by default. We would do our best to discover what we think is in there. But another beauty of big data connections is that you can update these properties so that you can use different geometry, different times, and different field names. So in this ship location properties, I've updated some of the geometry and time properties so that we can use an interval or different locations. So for the geometry, I've switched it from the lat and long for the GPS points to the shipping lat and long. So this is going to show us where the ships have left the port with their shipping cargo. And similar with time, I've switched it so that we're using an interval type time. We're using the ship date time, so when the ship left the port, and the receive date time, which is when the ship arrived at its destination. So that's just a quick overview of the flexibility of the properties in a BDC. Here are the messages that you'll get. You'll see all of the data sets that were registered. So now I'm going to go ahead and use these big data sets in a tool. So I have pre-populated this Find Well Locations tool. This is a tool that's pretty new, but it is installed. This isn't new like the big data connections, I should note. But this tool is going to find where objects have stayed in a certain distance for a certain amount of time. And as you can see in here, I have my Uber San Francisco data set in my big data source, and I've connected to it via the BDC connection. So in my map here, I have preloaded the input data. You can see that it's Uber data for San Francisco. With this tool, we're going to pretend that we're urban planners, and we want to find where these Uber drivers are commonly stopping and picking up or dropping off riders so that we can implement more safe and effective ride-share curb access. So Find Well Locations is going to need a track ID. This is going to say that we're going to search through each unique Uber vehicle. And we're going to find where the Uber vehicles are staying within 250 feet for 3 minutes. And we're going to show these dwell locations as convex hulls. So I'm going to go ahead and click Run at this point. You can see in my history here that this is only going to take close to a minute. But I am going to zoom into some points of interest from the results. So one of the areas of interest that we have discovered is this area here. This is actually an existing popular rideshare pickup and drop-off location, so now you know that you're finding the right things. Similarly, we have this laundromat and bank area, so it seems like a lot of people, I guess you guys know best, a lot of people might be going here to, pick with their laundry, taking an Uber and then going back. There's another area here. This is Union Square. We can find this one single dwell. But we can find some things like this, and you can apply these to your next city planning projects so that you can find where curbside access is a limited commodity or a popular commodity. And with that, we have seen how big data connections are going to be registered using a file location with various different formats. And we've also used the data set as input to a GeoAnalytics desktop tool called Find by Locations. And with that, I'm going to hand it back to Sarah. Thank you.
Cool. Thank you so much, Beth. Just a reminder, that's a preview of what's coming. Nothing's been finalized exactly, so names, terms might change, but we are excited to give that functionality because we know that struggling to use, multiple data sets as a single one is something you are running into. So with that, I want to give a complete summary of all of GeoAnalytics in Pro and kind of bring it home to what we're working on here. So GeoAnalytics in Pro is accelerated. It's speeding up your analytical processing time using built-in parallel compute. So there's no work for you to do to get Spark computing in parallel on your machine. All of this is just baked in. You have Pro, you run these tools. Spark is started up. There's no Spark install or anything crazy like that. And it's running in parallel on your machine, no matter what those parameters are. It's spatiotemporal, so many of these tools are designed to analyze data in space and time, and it's really important that we continue to work with those time components. It's integrated, it just works as is. So you have Pro, it's working. I kind of mentioned this in accelerated, but it is just so much nicer than trying to figure out how to go set up your own Spark setup and parallelize your analysis yourself. No more, figuring out how to query half your data set and then do the other half and combine the analysis later. And it's actionable. So some of the tools, or the tools that Beth showed, show us an ability to crunch through large volumes of data to generate actionable insights and intelligence. And it means that you and your organization can visualize and react to large amounts of data in a clearer and more meaningful way. I think, the integrated, I just want to add, it's so simple. These are just tools. If you're used to running tools, there's more tools available to you. So I don't think that could be a downside by any way. I want to thank you so much for listening to the whole section or skipping through and just getting the summary. That's totally fine too. I do have some links here. I will make sure that we get these on the YouTube video so that all of the links that we've talked about, these ones in particular, as well as any others that we have, are available to you. If you don't see any links, or if you have questions, or if you have really interesting use cases, you say hey, I'm using these tools, I'm missing this one thing, we want to hear from you. So definitely email us at geoanalytics-PEs. We're product engineers, that's what PEs is, at Esri.com. And thank you so much for your time.